Hello, there's Mr. Rops.
Hey, Mr. Cole.
And we today are going to be adding and subtracting surds. Okay. Oh, adding and surds. I forgot the subtracting. Subtracting. Okay,
Nice.
so it's not very grammatical, but I think you'll work with it. Okay, so before we do that though, I'm going to ask an algebra problem. Here's my algebra problem. I'm going to say negative 4x plus, let's say, y plus x plus 3y. If I say simplify that, Mr. Cole, what do you do to simplify that?
We need to get the ones that are alike together, don't we? So we can take our minus 4x's and our x and think how many x's is that all together?
Minus 3x's.
Yep.
And then we take our y's. We put them together.
Okay, so we've got 4y's.
4y's. Now, let's leave that aside for a second. I'm going to give you a surd problem, Mr. Cole. Here's my surds problem. Negative 4 square root 6 plus root 2 plus root 6 plus 3 square root 2. Now, why do you think I started with algebra, but we're really adding subtracting surds? I mean, this is my problem. Why do you think I did that, Mr. Cole?
Okay, so we're still looking for like terms, aren't we? So we can check that 6 is already, it can't be divided by any square numbers, and neither can 2. And then we can put the ones that are the same together.
So we're going to put those together and those together,
Yep.
just like the x's.
Right.
So, and similarly, we'll put the square root 2's together, just like the y's. So when we put it all together...
So we end up with what? 3 root 6? Minus 3 root 6?
Minus 3 root 6.
Add 4 root 2.
Okay, so that's how adding and subtracting surds work. You just collect like terms. Okay, so let's try another example of this scenario. Let's try this now. Let's say I have minus 4 square root 5 plus 3 square root 125. So if I'm going to do that, can I simplify? I can't add them the way they are. I got a 5 and 125. But this doesn't simplify. But what can I do with this 125 here?
Okay, well we can see that's a multiple of 25, isn't it?
It is indeed. So it is 25 times 3. And so if I continue to simplify, I can go 3. Square root of 25 is 5. And the square root of 3 just remains. I jumped a step there. I think you guys are good enough you can do that.
Hang on a minute, we've made a
Uh-oh.
mess up here, haven't we?
Where did I make a mistake?
It's 25 times 5, isn't it?
Oh, it is 25 times 5. Oh, good. This is not a 3.
Mr. Ropes was just testing, see if we're on the ball.
All right. Nice. So this should be 25 times 5. I wonder how many students copied it down incorrectly. Okay, so now, thanks for that. So we have root 5 plus 15 square root 5. And so now, again, now I can collect like terms, and I'm going to get 11 square root 5. Does that look like a 5 or a 6? Let me fix that and make it really clear so we don't have any issues here. This is a 5. Not a 3, not a 6, but a 5. So we simplify our surds, collect like terms, and we're done. Okay, let's try maybe even a more advanced problem. Let's jump to a really hard one. Let's say square root 12 plus 48 square rooted, and then a minus 18 square rooted. The way this looks, I can't add or subtract any of those.
This looks like we can simplify all of them though, doesn't it?
Okay, let's go for it. This I know is going to be 4 times 3 plus, I think that's 16 times 3. No, it's not. Is that right? Yes,
Yep,
it is.
yep, that works.
All right, good. And this is going to be 9 times 2. And so if I simplify this, Mr. Cole, what do I get?
So you got 2 root 3 there. Add 4 root 3 minus 3 root 2. Okay, so we can stick the root 3 ones together. So we've got 6 root 3's altogether. And we still need to take away 3 root 2's.
Okay. Now, this is the exact value. We don't have to put that in our calculator. We can just leave it as is. I think that's good enough for examples. I think they're set to try problems on their own.